Hey guys, good day. So welcome back sa ating channel. So ang topic natin is shear and moment coefficients. It's under ng reinforced concrete design. So shear and moment coefficients. So sa provisions from 2010 Nscp, basahin ko muna sa section 408.4.3. As an alternate to frame analysis, the following approximate moments and shears shall be permitted to be used in design of continuous beams and one-way slabs. One-way slab is slabs reinforced to resist flexural stresses in only one direction. Provided, so highlight ko lang yung ating yung approximate moments and shears. So pag tayo nag-analyze ng isang building or frame, so gumagamit tayo ng medyo madugong calculations or analysis. So pwede tayong gumamit ng cantilever method or portal method so para ma-analyze natin yung isang frame, para ma-design natin yung mga members, especially beam and columns. At ma-design natin sa bending and sa shears, yung ating beams. So pwede rin tayo gumamit ng mga software tulad ng STAAD. So sa Nscp, para hindi na tayo dumaan sa mga madudugong calculations tulad ng nabanggit ko, so nag-set siya ng mga approximate moments and shears na pwede gamitin provided na dapat masatisfy itong mga conditions na to. Una, there are 2 or more spans. So guys, may apply lang itong approximate moments and shears sa continuous beam slabs. Okay? Unang condition is there are 2 or more spans. Number 2, spans are approximately equal with the larger of 2 adjacent clear spans not greater than the shorter by more than 20%. Okay, una, okay na to. Lagi namang 2 or more spans ang ating continuous beam. Number 2, so dapat daw yung length ng ating mga span or beams is hindi dapat approximately equal sila. Kung may diferensya man, dapat hindi tataas ng 20%. Okay? So, yan. Number 3, loads are uniformly distributed. So, lagi namang uniform load natin. So, dead load, live load, lagi namang uniform yan. So, kapag mayroon tayong concentrated load, so hindi pwedeng gamitin yung ating shear moment coefficients. Number 4, unfactored live load or yung L does not exceed 3 times unfactored dead load. So, yung live load doon natin, service live load, hindi dapat lumampas ng 3 times ng unfactored dead load or service dead load. Okay, and last, members are prismatic. Sinabi natin prismatic, dapat same in cross-section yung ating beam and the whole span. Dapat pare-pareho sila ng cross-section. So, okay, dapat masatisfy itong 5 condition na to para magamit natin yung approximate moment and shears, yung shear moment coefficients. So, example to yung frame natin. So, ilang floor yan? So, fourth floor. So, kasi consider natin itong span na to. Kasi meron tayong 3 span. 1, 2, and 3. So, okay, pwede na siya i-consider pwede gamitin na shear moment coefficiency. Assume natin na lahat yung buong span is prismatic and uniform lahat ng loadings. Then, same naman sila ng lengths ng span. So, pwede natin gamitin yung shear moment coefficient. Kasi, kapag yung column ng ating supports, so ina-assume natin dyan na yung ating support is fixed support. Diba kapag simply supported yung ating beam, so simply supported, so meron tayo dyan, ang magiging shear and moment diagram niya is ganito. Shear, ganyan lang. Ang moment diagram is parabolic. Pag uniform load parabolic. So kapag fixed naman, naka-fix sa kabilaan, yung beam natin. So yun nga, column yan, so naka-fix. So ang kanyang shear, ganun din. As tayo dito, din baba. Ang kanyang magiging moment diagram, since fixed yan, meron tayo dito moment, negative moment. And ganun din sa kabila, meron tayong negative moment. So ang kanyang magiging shear moment diagram, so negative, then ganyan. So yung negative moment, ito yung positive moment. So may binigay na coefficient si Nscp. So ito yan. So positive moments, sa mga end spans, sa dalawang dulo, end spans, pag yung ating beam is discontinuous and unrestrained. So, pag sinabing unrestrained, hindi siya naka-fix. So, ang formula ng ating positive moment is WL squared over 11. So, babasahin ko lang itong W pero hindi siya talaga W. Babasahin ko lang W para mas madali. So, discontinuous and integral with support. So, ang formula niyan is WL squared over 14. Yan yung mga sa end spans. Kapag yung mga interior spans, WL squared over 16. So, pag negative moments naman, yung mga negative moments, yun, at exterior face of the first interior support. So, mamaya pakita ko sa drawing. Exterior face, sabihin panlabas na face ng ating first interior support. Pag 2 spans, WL squared over 9, yung kaya negative moment. Kapag more than 2 spans, WL squared over 10. So, marami pang negative moment, marami pa. At other faces of the interior support. So, yung mga faces ng ating interior support, maliban dun sa nabanggit kanina. So, ito yung WL squared over 11. Okay? So, negative moments ulit kapag at face of all supports for yung mga supports slabs with spans not exceeding 3 meters and being the ratio of sum of column stiffness to beam stiffness exceeds 8 at each end of the span, squared over 12. Negative moments at interior face of the exterior supports for members built integrally with supports. Where support is expander beam, ang formula natin is WL squared over 24. When support is a column, nga, WL squared over 16. Yun yung mga interior face of the exterior supports. Sa shear naman, shear end member at face of the first interior support. So, meron kayong add na 15% or 1.15 WL over 2. Diba? Ang shear naman is WL, paghahatian lang, so WL over 2 lang. So, dito sa shear end member at face of the first interior support, tandaan nyo na, dadagdag kayo ng 15%. So, shear at face of all other supports, so, yun na, WL over 2 na. Okay? Yan, note, ito yung mahalaga. Yung L, it is the clear span of for positive moment in shear and average of adjacent clear spans for negative moment. So, yung L natin, kapag gina-compute is positive in shear, positive moment, tsaka shear, so, yun yung clear span ng span kung anong kinukuha natin ng moment. Kapag naman negative moment yung pinakompute, so kailangan natin i-average yung adjacent clear spans. Okay? And then yung W is the total factored load. Factored pa. Pakita natin yung ating distribution. So, meron tayong continuous beam, no? Mayroong apat na span. Column, then hinge. So, gawa natin na shear and moment diagram. Ganyan yung shear, lahat naman yung ganyan yung shear diagram nila. Ito yung one moment diagram. Okay, unahin natin yung mga positive moments. Ito yung mga positive moments. So, ano ba to? Discontinuous end integral with support. So, WL squared over 14. Diba? Integral with support, support. And when discontinuous end unrestrained, ito yung mga end span, diba? End span, tsaka ito rin end span. Pag integral with support, ito yung WL squared over 14. Kapag unrestrained, discontinuous end, unrestrained, diba? Unrestrained to, hindi siya nakafix dito. So, WL squared over 11. Okay din yung mga natira, yung mga interior spans, WL squared over 16. Pwede naman tayo sa negative moment. Dito muna tayo sa exterior face at the first interior support. Ang formula natin, diba, is WL squared over 9 kapag 2 spans. Since meron tayong 4 spans, so WL squared over 10 dito at saka dito. Okay? Then yung mga ito, tsaka ito is negative moment at other faces of the interior support. Since ito interior support, WL squared over 11. Then dito, ang tira is WL squared. Ito ay interior face of the exterior support. Ano yun? WL squared over 16. So, yun yung mga negative moments natin. So, kapag yung ito is column, so yung negative moment at interior face of the exterior supports, when support is column, kaya WL squared over 16. Kapag spandrel beam, WL squared over 24. So, tandaan nyo na, doon naman tayo sa shear. Yung shear dito, sabi ko nga, dadadag tayo ng 15%, at saka dito, 1.15 WL over 2, doon din. Then yung mga natira, lahat yung is WL over 2 na lang. So, mahalaga ang tandaan dyan is yung L natin 2, kaya natin is clear span. Sabihin, ito lang po yun. Wala dito. hanggang dito. Yun po yung L na tinutukoy. Kapag positive moment at saka shear yung compute, so kailangan yung respan. Kapag negative moment, so i-average nyo po, since kunwari ang hinahanap is negative moment na to, so kailangan yung i-average itong span 1 and span 2. Okay? Tayo ng isang problem. So situation 1, a reinforced concrete floor consists of beam base times height is equals to 300 by 400 mm. Clear concrete cover is 50 mm. Length 1. Yung length 1 is center to center po ng column na 5.3 meters. Length 2 is 5.8 meters. Length 3 is 5.3 meters. Slab thickness 100 mm. Concrete strength or FRMC is 30 megapascal. Steel strength FY is 415 megapascal. Main reinforcement is 25 mm diameter. Ties is 12 mm diameter. For shear and moment calculations, use in the Nscp coefficient method. Yan. Assume 300 by 300 column. Ito yung importante dito. Yung column dimensions. Kasi is-subtract nyo yan sa ating span para makapit natin yung clear span. So number 1, find the shear or VU at end J of span IJ if the total ultimate load is 36 kN per meter. Number 2, what is the moment MU at end J of span JK if the total ultimate load is 36 kN per meter. So ito yung ating plan. Ito yung plan natin. Ito is mga column A, B, C, D. And mga column yan, yung span. Given na yung length is 5.3, 5.8, tsaka 5.3. So pinapakumpit sa atin is shear daw sa NJ. Saan ba yun? Of the AJ. Ito yan. Shear daw dito. Tsaka moment doon sa J of the span JK. Tsaka moment dito. Okay? So, yung consider lang natin ito na beam IJKN. So, ito rin ko consider natin. So, nilagay ko na yung length, 5.3, 5.8, tsaka 5.3 meters. So, yan ay mga center to center spacing, center to center of column pa yan ha, yung length na yan. Number 1, so yan. Ng column IJKL, nagets nyo ba? Ito yung ating cross section. So, ito may kita natin dyan. Ito yung plan. Ito yung section. So, length nyan is 5.3, 5.8, tsaka 5.3. Yung load natin, given na factor load na yung 36 kN per meter. So, span IJ, ito yan. Divide dito. Ang shear dyan is mag-add tayo ng 15% or 1.15 WL over 2. So, ang kailangan natin computin is yung L. So, yung L natin is 5.3 minus 0.3. Bakit naging 0.3? Kasi ito, di ba, ang clear span mula dito, hanggang dito lang ang clear span. So, 5.3, bukasan natin ang kalahati ni column is na 0.15 yan. Kabila is 0.15 din. So, 0.15 plus 0.15 is 0.3. Ibig sabihin, yung 5.3 meters, bukasan natin ang dalawang kalahati ng column. So, makakabuta yung isang dimension ng column na 0.3. So, clear span is 5 meters. So, substitute doon sa formula, 1 to 15, 36 times 5 over 2. Answer is 103.5 kN. So, it will be the shear doon sa ating J. Sa span IJ. Okay, iba pa yung shear dito sa span JK. Iba yung shear dito. Wala na yung 15% na to. Okay, ganun kapag compute kayo ng shear. So, try natin solve yung negative moment sa JK. So, ang tanong, ano yung magiging formula? So, kung gagawa nito ng shear diagram, hindi ba? Yung shear diagram. Ang shear diagram yan is yun lang rin. Tapos tayo ito. Ang moment diagram, syempre, may negative moment dyan. So, ganito. So, pinapakumpit natin is yung moment dito. Tama? So, ano magiging formula? W. So, yung load natin is 36. Kumpitin muna natin yung previous span dito. Kasi i-average natin yan. So, yung length natin is 5.8 minus 0.3 kasi kalahati ni 0.3. Kalahati ulit. So, buwasan natin. So, magiging 5.8 minus 0.3 na lang, magiging 5.5. So, average natin. Yung length rin natin is 5.5 meters din. So, kailangan natin i-average ito sa L1 at saka sa L2. Hindi L3 ha, mali yan. L1 po yan. So, 5.3 plus 5.8. Kasi yung pinapakompute is span JK. Diba? Moment sa J. So, 5.5 plus 5 divided by 2 is 5.25 meters. So, WL squared divided by 11. Bakit naging WL squared divided by 11 yung ating negative moment? Kasi ito is the other faces of the interior support. Kung dito, exterior face of the interior support is WL squared over 10. Tama? WL squared over 10. Kung dito is WL squared over 11. Kasi at other faces of the interior support. So, substitute na sa formula. 36 times 5.25 squared over 11. So, guys, ito ay correction na. L1 yan, L1. Kasi ito yung kailangan nating i-average. Ito at saka ito. So, answer is negative 90.205 kN meter. Okay, ganun lang. Pwede nyo kumpitin yung ibang unknowns gamit yung shear moment coefficients. Okay, kasi kung ano ba yung pinaka-purpose ni Nscp, bakit naglagay siya ng mga coefficients. So yun nga, para mapadali yung calculations natin, kasi kung hindi tayo gumamit ng mga coefficients na yan, so pwede tayong gumamit ng mga maraming method. Pwede tayong moment equation method, or deflection slope method, o pwede rin sa software, sa stat, pwede natin gamitin para makompute natin yung mga reactions sa column na to, din yung shear and the negative moment or critical moment sa ating members. So, ito yung para mapadali. Approximate lang ito. So, hindi ito yung exact value. Okay? So, try natin ito. Situation 2, it is Seaboard, November 2016. For shear and moment calculations, use the Nscp coefficients sa section 408.4. Given spans are referred to the center line of the supporting columns. So, yung L1 is equal to L2, 6 meters. L3 is 7 meters. Yung S, 2.5 meters. Beam section is 350 by 450 mm. Slab thickness, 100. And use the dimensions for column is 350 by 350. So, mahalaga ito. Yun yung isa-subtract natin sa length para makupit natin yung pier span. Ang materials, ang kanyang FM system 7.5, ang FY is 415 megapascal. Loads, ang load combination is 1.2 dead load was 1.6 live load. So, given yung ating dead load, ang factor dito na 5 kilopascal. Kaya, kilopascal yan. Ang live load is 3.6 kilopascal. And number 1, what is the moment at end F the beam EF? Find the moment at midspan of beam FG. What is the shear at end F the beam EF? Ayun na is moment, and shear. What determine the maximum moment? Okay. Find the value of the maximum shear. Determine the maximum reaction. Okay, minimum maximum. Ito yung ating plan. Katulad na rin sa situation 1. Yung P to, iba na yung length. 6 meter, 6 meter, 7 meter. Given na yung 2.5 na spacing ng ating mga columns. So, ang kailangan natin unang gawin is given yung dead load tsaka live load, diba? Ang consider naman natin dito is itong center to center, yung tributary area. Center ng load. Since ang binigay sa atin is na kilopascal, diba? Ibig sabihin pressure yun. So, kailangan natin siya i-convert into kilonewton meter. So, ito yung ating beam EFGH. Ayan. Meron tayong 3 span. So, yung length is 6 meters, 6 meters, tsaka 7 meters. Yung load, kailangan natin computin yung W. So, kung load combination is 1.2 dead load plus 1.6 live load, papaliwanag ko sa inyo para computin yung dead load. So, ito yung kinonsider natin. So, kalahati ni 2.5. Diba? Ito kalahati ni 2.5. Ito kalahati ni 2.5. So, ibig sabihin, yung total natin na i-consider natin o ipapakarga natin sa beam EFGH is 2.5 meters, diba? Kasi kalahati is 2.5 din yan. So, ito lang yung kakargahin ni beam EFGH, tributary area. So, since ang ating load is kilopascal, so 5 kilopascal, kN per meter squared. So, kailangan natin siya i-multiply sa meter. Anong meter yon? 2.5 or 6. So, para ma-distribute natin siya sa length na to, o sa length na ito, yung length na to, para ma-distribute natin siya sa length yan, so kailangan natin siyang i-multiply sa length na to, na 2.5. Yun na. Kasi kung pag minultiply natin sa 2.5 by 6, so makakompute natin is concentrated load. So, kailangan natin is uniform load, na kN per meter. So, i-multiply natin siya sa 2.5. Gets ba? So, 5 kilopascal times 2.5 will be 12.5 kN per meter. So, live load, ganun din. 3.6 by 2.5 will be 9 kN per meter. Then, apply natin yung load combination. Factored load is 1.2 times dead load plus 1.6 live load. Ang total factored load natin is 29.4 kN per meter. So, nagas yun ha. Laboratory area po yung ginamit. So, kung consider nyo rin is, kung nag-consider nyo is beam IG, ganun din po. Kalahati nito, ito po yung kakaragayan ng beam IG, KN. Okay? So, ito tayo dito. Nakuha natin yung total load. So, ilagay natin yung shear in moment diagram. So, clear up. Clear span. Clear span. So, dito lang. Position niya ng drawing ko ha. So, yun. Ang pinapakumpit sa number 1 is yung shear. Ay moment muna sa F. Yung moment yan, ito yung shear. Yung moment niya, negative moment yun. So, kailangan natin i-average yung L1 at saka L2. So, L1 natin is 6 minus. So, kalahati ulit ng column. Kalahati ulit. So, minus ng isang dimension ng column. L1 is equals to L2 is 5.65. I-average nyo yan. 5.65 plus 5.65 divided by 2 is 5.65 pa rin. So, ito yan, hindi ka nakapinakita yung pag-average. Okay na? So, yun. Anong negative moments kapag exterior face of the interior support? Exterior face of the first interior support is WL squared over 10 kapag 3 or more spans. Kapag 2 span, WL squared over 9 lang. Okay, tandaan nyo. So, ngayon yung moment at F. Since meron na tayong load na 29.4 times na length na 5.65. Yun na. Moment F is negative 93.85 kN. Kung sana naintindihan na, i-average po natin yung length. Hindi ko lang pinakita dito kasi na 5.65 sila parehas. So, next is moment doon sa FG. Since ito ay interior span, di ba, ang positive moment po sa interior span is WL squared over 16. So, kapag hinihingi is positive moment, so no need na i-average pa yung length. Kung ano yung field span, yun na po yung ating gagamitin. So, positive moment yan, so WL squared is 29.4 times 5.65 squared over 16. That will be 58.66 kN meter. Okay? Next is shear. Hindi natin shear at F. Yung shear nasa F, diba, is shear in end members at face of the first interior support is darated tayo ng 1.15%. Ay, ng 15%. So, 1.15 WL over 2. So, ang gagamitin natin span dyan is yung clear span na 5.65. 1.15, 29.4 times 5.65 divided by 2. That will be 95.51 kN. Yun. So, ito yung yung next 3 questions is maximum na. Maximum shear, maximum moment, and maximum production. Okay? So, number 4, ang hingin sa atin is maximum moment. So, ganito yan. Kanina nga, balik natin. Yan, lahat yan, di ba, may moments. Yan, lahat yan may negative moment, positive moment. So, ngayon, yung napupit sa atin is maximum moment. Ito. Di natin alam kung saan ba yung pinakamalaking moment yan. So, ang pwede nyo gawin, kung gusto nyo mag-exhibition, so, isolve nyo lahat. Isa-isahin nyo lahat sa growth of profit. So, parang dami mo minsan mag-exhibition kayo. So, ang pinakamabilis na discarte dyan pipiliin nyo yung, since pare-pareho lang silang WL squared, so pipiliin nyo lang yung pinakamalaking length, at the same time, pinakamaliit na denominator. Okay? Kasi mas maliit na denominator, siyempre mas malaki yung result. Or quotient. So, since ang pinakamalaking length is 7 meters, automatic nasa G yung ating maximum moment. Pwedeng dito, o dito. So, ano ba yung formula dito? Ito ba is WL squared over 10 dito, exterior face of the interior support, and dito is WL squared over 11. So, pipili natin is WL squared over 10. Kasi mas maliit yung 10 sa 11, so mas malaki yung result na ibibigay niya. So, hindi natin isa-isahin yung moment. So, alam natin yung maximum moment is WL squared over 10. So, ang kailangan natin computin is yung kanyang average clear span. Kasi negative moment yung pinakompute. So, kung average ito is 5.65 plus 6.65 kasi ito ay yung clear span niya is 5.65. Ito ay 6.65. So, that will give us the value of 6.15 yung clear span natin gagamitin. So, yeah, negative WL squared over 10. Yung liwanag ko na, bakit yun ang ating maximum. So, 29.4 times 6.15 squared over 10. Maximum moment is negative 111.188 kN meter. So, kahit kumpitin nyo pa yung ibang moment, so walang tataas dito. Ito na yung pinakamalaking moment. Okay? Then, pinapakamit sa number 5 is the maximum shear. So, since ang maximum shear, pwedeng nandito yung maximum shear. Sabi ko nga, pinakamalaking length. Automatic, nandito yung maximum shear length. Nandiyan yung maximum shear. Kasi nandito yung pinakamalaking length eh. Lahat naman sila is 2 yung denominator. So, pipiliin natin yung pinakamalaking length. So, 1.15, 29.4 times 6.65, which is yung bent span nito, clear span, is equals to, maximum shear is 112.418 kN. Again, kung gusto nyo kumpitin isa-isa, pwede rin. Kung gusto nyo may exhibition, pwede. Pero, doon tayo sa mas madaling solution. Piliin nyo na yung pinakamalaking length. Okay, next, maximum reaction. So, since nandito yung maximum shear, automatic nandito na yung pinakamalaking reaction. Ito yung reaction sa G. May reaction dito sa F. Kung gusto nyo kumpitin nyo rin. May reaction din sa E. May reaction din sa H. Pero sure ako, nandito yung pinakamalaking reaction sa kasi nandito yung max. Kailangan natin kumpitin is yung shear dito sa kabila. Is WL over 2 lang yun. Ang L na gagamitin is 5.65. Yung shear sa G. 79.4 times 5.65 divided by 2. That will be 83.055. So, consider natin itong column na to. Yan yun. So, yung shear dito sa kaliwa is 112. Yung shear sa kanan is, sa kaliwa is 83 pala. Sa kanan is 112. So, yan. Then, ito yung reactions sa G, which is yung Rmax. Submission force vertical. So, mataas si Rmax. So, 83.055 plus 112.418 equals to maximum reaction. So, Rmax is equals to 195.473 kN. Ganun lang. Last problem. A continuous beam is to be subjected to a total uniform dead load of 10 kN per meter and total live load of 25 kN per meter. Using the Nscp coefficient method, load combination is 1. I'm going to dead load plus 1.6. Compute na natin yung compute the total factored moment at E, compute the factored moment at D, determine the factored shear at D. So, ito yung ating figure. So, meron tayong 3 spans. May length na 7 meters, 8 meters, at 7 meters. Mayroon ditong axial load sa point G na 567.2 kN. So, hindi naman natin siya magagamit siguro. And this, ang dimension ng column ito, mahalaga ito. Ang dimension ng column natin is 0.5 by 0.5 meters. Typical. Sabihin lahat ng column natin is 500 by 500 meter or 0.5 meter. Ang pinapakompute natin is factored moment at E. So, ano yun? Max na ano yun? Positive moment. So, interior span is WL squared over 16 na natin. Kumpitin muna natin yung uniform load, yung factor load, 1.2 dead load, plus 1.6 dead load. So, uniform load natin is, total uniform factor load is 52 kN per meter. Then, kumpitin na natin yung moment dito. So, clear span muna. Yung clear span natin dito is 8. Buwasan natin ang kalahati ni column, 0.25, dito 0.25 din. So, ang clear span natin is magiging 7.5 meters. Okay? So, yun yung ating gagamitin dito. WL squared is 52 times 7.5 squared over 16. That will be 182.81 kilonewton per meter. Then, moment sa D, since negative moment yon, WL squared by 11 lang yun. So, kailangan natin clear span nito. 7 meters minus 0.25. Yun. Bakit 0.25 lang? Kasi dito, column yung support, so kalahati lang ni 0.5. Dito, hinge. So, mula dito hanggang dito, ito yung clear span niya. Na 7 minus 0.25 is 6.75. So, naintindihan nyo na. So, kalahati lang ni column yung ating support. So, i-average natin itong dalawa. 6.75 plus 7.5. That will be 7.125 meters. Okay. The average length is 7.125 meters. So, ang WL squared over 11 kasi dito rin WL squared over 11. So, 52 and 7.125 over 11, it will be 239, negative 239.8 kilonewton per meter. Last, may shear sa P. So, ano ba shear dito? WL over 2 lang. Dito, 1.15. WL over 2. Dito, 1.15 din. Dito, WL over 2. So, okay, WL over 2, 52 times 7.5 kasi yung clear span nito. Ay, dito pala. Ito. Yung tinatanong is 6.7 kilo. So, shear at P is 195 kilo. Okay? Yun. That's it. Sana naiintindihan niyo ang shear and moment coefficient at saka bakit siya ginagamit. At huwag niyo kakalimutan na yung mga conditions bago i-apply yung shear and moment coefficients. Ito na lang. Sana natapos niyo yung video. And mag-solve na mag-solve. Good luck.